Question number 34. A plane of a coil is positioned at right angles to a magnetic field of flux density B. The coil has n turns. Okay. Each of area A, the coil is rotated through 180 in time t. What is the magnitude of the induced EMF? Okay. Now what we will do is, for this problem, let me first label this coil. Let me call this as P, Q, R and S over here. Okay. Initially, this is the way how it looks like. So as a result of it, the aerial vector is now like this over here. Okay. Now in the second configuration, I am going to rotate this by 180 degree. When I rotate it by 180 degree, how does the configuration look like? Configuration will now look like this over here, right? This R and S will come to the top. R and S will come to the top. This P and Q will come to the bottom, right? So you flip it like this. So this will be your Q and P will come here, and this will be your armature, which means the line that I have drawn here would be flipped like this over here, right? Now, what is the phi vector given by? Phi vector is given by NBA cos of theta. This is what is given. Now, what is theta here? Theta here is nothing but the angle between the aerial vector and the magnetic field. So, what is this value here in the first case? Now, okay, before that, okay. Now, how do I get an induced EMF on rotating this? Which means what? So, your delta phi should change. Okay, why? How does it change? Upon changing this one, does the value of n change? N does not change. B changes? No, B does not change. Same magnetic field. Area, aerial vector also does not change. But the orientation of this aerial vector changes over here, right? So therefore, initially this should be cos of like this, which is 180 minus what is the final one? Final one is like this, which means what? It's along the direction of the magnetic field. So the angle between this vector and the magnetic field is 0. It should be cos 0 over here, right? Cos 0. So if I substitute this, I get this as NBA into minus 1, which should be equal to minus 2 NBA. Okay. And if I divide this by time, only then I will be able to get the induced EMF, right? So delta phi by delta t, this happens in a time t. So this should be equal to minus 2 NBA divided by t. Okay. And if I take the negative value here, this will give me the positive here. So which will now be equal to E, right? The induced EMF thus will be equal to 2 times NBA divided by t, which is nothing but answer D.